Thanks for coming, everyone, to a keynote here at SD&A. And it's a great pleasure to introduce our speaker today, Tim Macmillan, who's the creator of this really captivating time-slice multi-camera technique. As CEO of TimesliceFilms, he's been producing a variety of really wonderful frozen time videos, so to speak, which you should really check out. A lot of them are online. Now a consultant, he just previously was senior manager of advanced products at GoPro. He's won numerous awards, including Best of NAMM, for his Omni GoPro spherical system. So Mr. Macmillan will present on behalf of himself and, I believe, colleague David Newman, right? Senior Director of Software Engineering at GoPro. Take it away, sir.
Hi, everybody. This talk is going to be a little bit oblique. I know I'm in stereo displays and everything, and stereo is very important. But what I'm going to do a little sort of dive into the past, because there's something very important I want to show you and that I think you should understand. And then we'll kind of move on into the future. And bear in mind that I'm not coming at this from an academic standpoint. I'm coming at this from a real-world product person standpoint. You know, how do we get new ways of imaging into the consumer market? How do we get people to accept them? How do we get people to use them? So here we go. Anyway, so let's go back to, when was it? 1982. So this is me with two of my very early time-slice cameras, which I'd sort of invented 2 years before that when I was doing my graduate studies. And this is at the University College London here. So basically, I discovered, I kind of reverse engineered cubist theory and came up with the idea of a camera which could capture, you know, an object or a space from many viewpoints simultaneously. So I started building these cameras to do that. And that kind of got me through my graduate. And then I went to the University College to do postgraduate, where I could develop these cameras further. I wanted to build a circular camera to produce a kind of continuous tracking shot. And in the University College, you've got the Slade School of Art where I was. And within, 20 feet or so, I could be in Egyptology, I could be in nuclear physics, I could be in astrophysics, I could be in the University College Hospital. I was kind of talking to a lot of different researchers and scientists, and I would have a little exhibition of my work, and the scientists would come along and say, "That's amazing, Tim, but it's very arty." And the artists would come along and say, "That's amazing, Tim, but it's very sciencey." So way back then, I realized that there was a kind of space in which you're trying to take from one field and kind of push it into another. So let me just try and, this thing jumped a bit. Yeah. So these cameras are now in the Science Museum in the United Kingdom. And this work was very difficult back then, because back in the early 1980s, what was hip and trendy was U-matic video and VHS and all this sort of thing. So somebody messing around with kind of MyBridge type technology was very difficult. So let's jump forward to, this is, hopefully we'll have audio. Audio? There should be audio coming over extension 1. Oh, why is that? Hang on a second. Why is it saying my audio's blocked? All right, let's try again. That's better. Let's see. Okay. So 1993, this was Tomorrow's World, a science program which debuted this effect. This is one of the very first kind of images that we took of a frozen moment.
are no shutters on, so the picture has to be made working in the dark using a flash. Layer exposure, simply take your subject and tuck it through the loop, triggering a flash. Now, the resulting strip of film delaminate into a loop produces a mini movie of that single moment in time. It looks quite arty, so sit back, relax, and take a look at these.
Yeah. So that's an important moment. I'll tell you why, because the Tomorrow's World Science program was a live program, so I was in the studio when it was being broadcast, and literally 5 minutes afterwards, some secretary comes running up to me, says, "You've got to come to the BBC switchboard." I said, "OK," and we go to the BBC switchboard, and there's chaos because they're getting thousands of calls about a dog that had been killed on television. And now we can understand this. We can understand, OK, so the dog is just frozen in time. It's not frozen in its life. I didn't dry freeze it in a single instant. And the presenter explained the camera. This is the camera. It has pinholes. Each of them exposes, and then you put it on a strip of film and you project it. But the audience reaction, is a different thing altogether. And this is way back in 1993. I realized that there's something very important with what I would call social currency, of images. What does an image mean to people? What's its value? And what happens when you disrupt that? So this is something which I'm going to focus on in this talk about. This is something we should be very careful of when we're kind of bringing new technology to the world. So here's the very first TV commercial from, I think it was 1995. There's the camera I built to do this, and it used Kodak lenses. Unfortunately, Kodak sent me the lenses in a box, and they weren't packaged, so they're all scratched. And anyway, so plastic lenses. So anyway, so we went around London. We did this kind of frozen moment of time in London, and it was for Capital FM, a London radio station. So the punchline is London is static without Capital FM, But again, the kind of results, when you looked at the viewer analysis for this commercial, it was very split. And it was split sort of generationally. The under 30s loved it, got it. The over 30s thought it freaked them out. They really thought it was spooky and nasty and didn't want anything to do with Capital FM. So it was a groundbreaking commercial, but also it kind of broke a bit of Capital FM's audience. So again, it's like this social currency thing. And looking into the reasons for that split in kind of audience appreciation for that was very interesting. And I want to show this. This is why the under 30s got it and the over 30s didn't. And this is what is driving a lot of the way we are using technology now to capture images and to kind of things that are changing the meaning of images and the linguistic ways we use images. Just look at the way the camera moves in this. I mean, this was stunning. This was groundbreaking. I'd been working in the industry, as you see on the right, with cameras. I've been doing stuff with IMAX and stuff. Enormous cameras, very heavy. They have inertia, they have weight, they have crews, they have equipment and stuff. You can't move them like this. This is elastic. This is what we now call free viewpoint. So what's happening here is, in computer gaming, you're setting up a kind of nascent demand for the camera to do this. And what comes after this? What comes after this? You have YouTube create the platform, and then someone like GoPro comes along, and everybody wants the POV camera. And now with drones, everybody wants the third-person view, just like this, you know? So these are kind of strong social trends which move through society. And you can't just look at the camera technology and say, everyone's going to do this because it's great. These trends, these things happen, you know, because of multiple inputs, you know, multiple causes. Let me just check So anyway, that's me, again, with one of my more sophisticated time-slice cameras. And so I realized what I was doing was actually on a mission to actually achieve, eventually, what I saw in gaming. This is what this is the pull that people would put on how they want images, how they want to consume images. What they see in gaming, they want to see in real life, basically. And if you look at cinema, since that point, you'll see this trend very, very clearly. But this is I went after the freaky experience with Capitol FM. The people in the commercial world and the film world were like, "Oh, this is too dangerous. We don't want to touch this effect." But the people that really loved it were the natural history people. They said, "Hey, yeah, let's go all over the world. Let's shoot animals, freeze them in time, because it makes great natural history documentary material." So I built some cameras, high-quality lenses, used VistaVision large 8x format movie film. That's the camera on location in, where was that? Cabo San Lucas, I think, in Mexico, and filming penguins. So it was great. And it was nice that I was able to kind of keep developing the technology and the techniques, you know, under the kind of patronage, shall we say, of BBC Natural History. It was very exciting. It was very scary as well. There are some animals I'd recommend you do not work with, like tigers, lions, crocodiles, snakes, all that shit. Don't. Have someone else do it. So there we go. So what's also interesting about this is that this is way before stereoscopic TV and everything, but the time slicing gives you that arc, it gives you parallax, you're able to kind of experience the animal in like what we call 2.5D. But then around 1998, things start to change. Principally software started coming in. So there's me out in South Africa filming great white sharks, but not with a big time slice rig with 10 Nikon cameras, because it's difficult to get a 300-kilo rig exactly where a shark is going to jump. I could do it with the dolphins because dolphins are intelligent. Sharks just don't give a shit. So I had to use long lenses, and we towed a seal, like a sea lion decoy, rubber seal. And then one morning the shark kind of hit it and came out the water with the seal in its mouth, and I got the shot. But what was happening then was the early days of interpolation software. This is one of the very first algorithms that came out from a company called Snell and Wilcox. It was called Flomo. It was actually used on the Matrix to kind of solve a lot of issues they had in shooting on the Matrix. So there's the original 10 frames on the left. And then in a cafe in Cape Town, I had the film scan, sat in a cafe with my little O2 computer and command line. I generated the several hundred frames of interpolated stuff there. So again, I'm getting a bit closer to that Lara Croft thing. I'm getting a bit closer to a nice, smooth virtual camera move. A lot of frequency issues to do with waves and stuff, but that's beside the point. Anyway, so this is, if we move on to 2000, now we get DSLRs, digital single-lens reflex cameras, with a large, beautiful, flat sensor and pixels. Whoa! Algorithms love that. They love stuff to be flat on the same plane, and this pixel correlates to that pixel, so yes, I can do it. So this is, we were using revision effects, Twixtor. There was software from the Foundry called Kronos, and we were still also using the original Flomo command line stuff from Snell and Wilcox, because each of them had issues, and another program could fix the issues that one program had. So anyway, between all three of them, it worked out. And this was a thing I did for the BBC. It was something, what was it? Miracles of Jesus. So we filmed these miracles and caught the miracle moments and stuff. And I'm on a sort of Rembrandt gig here with the lighting and stuff. I was asked, commissioned to do this thing on the miracles of Jesus. I thought, how do I do that? So I went to the art galleries and saw Rembrandt. And that's how I do it. Yeah, Rembrandt. Again, kind of cultural references, so people get some sort of reference there when they see the image. But again, we're getting closer and closer to that Lara Croft thing. Right. So then I joined GoPro in 2012, and been working 2012 to 2016 last year, and doing GoPro Array. And with GoPro Array, Video Array, as you can see in this, you're able to move around, change your viewpoint, freeze, action. It's quite fun. Again, we're getting much closer to the Lara Croft thing, We've got this elastic kind of connection going. And I love these guys whacking each other with their swords and stuff. It is still not quite there. You're still bounded by the actual length of the rig and the cameras, whereas what you really want is to move anywhere in space. Yeah. There's some examples down below of the GoPro Array stuff. Underwater GoPro arrays, and also starting to work with 4D capture with the top right. I think I showed that last year, the 4D capture stuff. But that is, again, taking us towards that free viewpoint camera. Yeah. So, right. So, one of the great things about coming to the States is I've been able to connect with Paul Debevec down in LA and his light stage. Because again, I think this is a very exciting way. We can potentially combine multi-camera technology and his light stage to produce something quite awesome. Anyway, I'm a happy chappy in that sort of environment. Yeah, and this is what I did at GoPro. So we started off with the dual hero system, the stereo system. Unfortunately, this came out just as the market for 3D crashed, the consumer market for 3D. I have very strong opinions about why the consumer market for 3D crashed, but anyway. The nice thing about this was if you took that 2.7K stereo and put it on a 4K stereo monitor, it looked extraordinary. I mean, it was like an order of magnitude better than the HD stuff. You saw that and you looked at the HD stereo and you went, no, I never want to see that again. And then since then, using the synchronization that we developed at GoPro, we're able to make both the arrays, as you see there, and also the Omni and Odyssey cameras here. I would say this is not easy. There's something about multi-camera stuff which is very difficult, and that's the statistical probability of failure. Yeah. The more cameras you have, the more statistically probable it is that it's going to fail. Okay? If you have a glitch that happens once every 100 shots, by the time you have 100 cameras, it's going to happen every shot. Yeah? So there's the kind of issues you're kind of dealing with. And it was very difficult to actually, how should we say, bring the engineering and tolerances that we needed to make arrays work into a consumer camera. Because the consumer camera is very heavily defined by the cost of the components, the BOM cost, the ROI, everything else. So this was a kind of an ongoing struggle, but GoPro liked it because it gave them really good marketing. And actually, we ended up with these two kind of amazing products, which are out in the market now. So, one example of the work we had to do is back in the Hero 1, Hero 2 days, I analyzed the pointing errors of the camera. And when you put them in an array, something like this, you could get up to 300 pixels of pointing error because of the build tolerances in the camera. But gradually that fed through the kind of production, design, and production, and we ended up with something like shooting 4K or 2.7K about 30 pixels of pointing error, which is stupendous for a consumer camera of that nature. And the synchronization was, we put it on the bench and we found there's a 2 nanosecond delay between each camera, which is insignificant. So we were able to actually do some real rocket science there. Right, so let's think about disruption. How can you appraise, disruptive technologies for the market? So let's say you've got some sort of brand new technology. How can you look at it? One is product, one is consumer. So on the product side, you can look for positives. Is it a differentiator? Will it stand out from the crowd? Will it create a new product space or category? Will it drive cost efficiencies? People always like to do more for less money. Yeah? It's kind of obvious. Does it give me more power and efficiency in what I do, and does it solve any problem I have? Does it solve any needs I have? And there's also negatives. Will it disrupt existing work practices? What is the financial load? How invested are people in the current technology and practices? Will it disrupt infrastructure? And again, what's the financial load for that? And how invested are people in the existing infrastructure? And what is the ROI? Especially for people that buy these things. Because it's okay in the consumer world, people buy something and then a year later they just stick it in the bin, throw it away. But if you're talking to professionals or anybody that creates content, they have to see return on investment. Yeah? If you're creating a camera for too small a market, for too much money, they're not going to see a return on investment, and that will die. Okay? On the consumer side, let's have a look. Come on. Come on, come on. Work. There we are. Okay. On the consumer side, there are positives. Value add, like I said, people like more for less. Novelty is a great driver. Novelty will always sell things, but it's very short-lived, and you don't have a good business roadmap with novelty. Is the product going to be supported by companion or competitor products? Is it part of a growing trend? Is the product aspirational? A lot of people like to buy something which is more capable than they are. Yeah? You all drive cars. How fast can they go? And how fast do you drive? Yeah? You all like something that is a little bit beyond your capability. Makes you feel good. But then there are negatives as well. And this is where the social currency and language comes in. The image, all images have value, which is based on how we kind of perceive the image, how we read the image. Is it useful? Does it have intent? Does it say what I want? So we've got to think about how will our product affect this value, and what sort of load am I going to put on people when they're kind of viewing this. And what We've got to look at what's happening in related fields as well. It's like the thing with the Lara Croft thing, that was in gaming, but it's had a huge impact on the way we shoot, create, and view regular sort of video, film, images, and what have you. Right. So here's where we get contentious, okay? Let's take an example. GoPro versus Lytro. Okay. So I would say, looking at it from my perspective, Lytro did not consider the social implications of what refocusing does. Yeah? Refocusing alters the meaning in the picture. Yeah? The consumer is not so interested in focus. They like everything wide and sharp, me and the mountain, me and my friends, Cell phones are continually trying to get wider and wider lenses so people can get better and better selfies and group shots and everything else. People want inclusive pictures. From the professional standpoint, the professional is the auteur of the image. There are copyright lawyers. There's ownership. If you refocus an image after the event, who owns the copyright on that? Who is the originator? Is it the editor? Is it the photographer? Is it the, It creates a huge disruption in the kind of social currency, actually the real currency, because people have to make a living. And also the camera is very low resolution. Light field in that sense decimates the resolution. So what you end up saying is, well, actually existing cameras offer more for less. People would rather go for resolution, and people would rather see something that they understand. So again, you have it's a novelty, it's a trend, and it kind of just disappears. If we take GoPro, it's kind of the opposite case. It's a very powerful capture device, very high image quality, very happy. People, shooters, consumers, professionals, all very happy with it. It was a differentiator through image quality. It had initially some novelty, but it was part of a big trend. It was an aspirational thing, and it doesn't disrupt the social currency. It actually augments it. It creates a new area, a new territory of, let's call it the sports camera or whatever you like, life camera, all this thing. So I'd say clever disruption is about disrupting just a little thing at a time. Don't overload it. All right. So I'd like to talk about essentially this in terms of market pull and market push. So what we see a lot of, with new technologies is this market push, like the Lytro thing. This is great, this is fantastic, let's push it into the market and see what happens, Well, you've got to look at the, other things, its context first. However, there is market pull. There is nascent demand out there. You might not realize it, but there is. I know, I speak to some people very much of the thing, oh, well, let's just make stuff and see what sticks, It's like CES this year, going to CES and seeing all the cameras and everything. It's like throwing shit at the wall and let's just see what sticks. But you can be a bit more clever than that, and you can understand why some things will stick and why some things won't stick. All right. And all these things, these trends, revolutions in imaging, what have you, they don't appear out of nowhere. They do have cause. Maybe you can see it in retrospect when you analyze it, but they do have cause. So, what's happening in the spherical market? So we started off with this 4 years ago. Ricoh, fantastic camera, wonderful, wonderful. Brilliant design, fantastic lens design and everything. Real camera people, Ricoh, I love them to death. And then boom, this is sort of CES this year, and this isn't even half of it. I mean, if I put everything up there, it would look like a Jackson Pollock painting. There's just so much. In 4 years, you think, what the hell? Where's this coming from? And you could split them into maybe sort of 4 rough categories. Consumer portable devices limited to 4K by 2K to show on the mobile phone. They're mostly twin lens, twin lens, kind of back-to-back configuration, and they're 2D cameras. And then you get professional 4K to 8K, like the Omni camera there. And there's live stream stuff, 4K by 2K-ish there. And then there's the high-end, the kind of professional market with stereo 3D. And these things range from $100 at the bottom to like $60,000 at the top. So it's a huge disparity there. So at the top end, let's look at our stereo cameras here. So Jaunt, there isn't really any price on that. They don't sell it. Again, I think because there isn't, by the time they've sold 10 cameras, maybe they've saturated the entire world market. It's they're between a rock and a hard place, pretty much. But then Ozo came along and started kind of digging into that space and expanding it. So also, none of these rigs are truly spherical stereo. Nobody's doing true omnidirectional stereo. These are all kludges. They're all doing equatorial stereo. And if you look up and down, it's not stereo. And interestingly enough, looking at feedback from users using Ozo, they're not using 8 lenses, they're using 4 lenses, or even 3 lenses, because they get better image quality, less stitching issues. Yeah? So there are forces beginning to come into play here about where this market will go because of these kind of very rational reasons to do with, production and what have you. So Ozo compressed raw workflows. They've got a lot of post-production tools there to help everybody. And the other thing is, let's look at the Facebook, the Ozo, and the Jaunt, is they're using machine vision cameras and global shutters. And again, a very rational decision, but has a huge impact on image quality. And image quality drives what people want to see. Yeah? So I'd say rethink that. The GoPro rig uses CMOS rolling shutters, but extremely high image quality. Yeah? GoPro put a huge amount of effort into image tuning and making sure that what you got out of it was exceptional, much better than anybody else. So the GoPro rig is like 15K. The Facebook thing, they say, is about 30K, and it's just a template for people to follow. Again, because no one can see an actual market. Ozo are trying, but I think they're having a really, really hard time. So anyway, also one of the things there, if you go stereo, then you want parallax, don't you? So that means the camera gets big. Yeah. You want resolution, you want parallax. So the things just get huge and heavy and power hungry and expensive. Yeah. So let's look at the kind of middle range here. The these people here, I've forgotten their names, the 360 Pro. You remember their name? Insta360 Pro, Chinese people. It looks like they were looking at the customer feedback from the Ozo and making something a bit more rational. It's 6 cameras, kind of equatorial. And they're saying you can get 4K, 2 4K streams and 1 8K stream, 8K image out of it, not streams. Samsung Beyond, we don't know much about it, other than the developers were shouting at Samsung to go 8K, not 4K, because 4K just looks terrible. And then we've got other stereo systems coming out, which, may be good. I don't know, but they've yet to be kind of proven in the market space. And let me just get this to work. No, go back. There we are. And then we've got the small stuff at the top. I think the one that stands out is Ricoh, because they really understood the market they were going for, and they really understood the issues with disparity and stitching. because one of the things that people have to take into account with spherical is image quality. And image quality with spherical has to include stitching. You can't just look at the individual camera. You have to include what's going to happen with the stitching as well. So, you know, the Ricoh camera makes it very easy for the consumer to see a good image. Let me just scroll down here. OK. Right. So let's look at the 3D spherical in kind of the context of the pull and push of the market. So 3D spherical differentiator. It's difficult to say it's a differentiator because it's a closed loop at the minute. You can't really compare it against anything else. Cost efficiency is very low. It's complex. It's expensive. Efficacy. Yes, but it's kind of out there to fix a short-term problem because 3D does give you a slightly better experience given the very low resolutions you're looking at this stuff on at the minute, you know, on HMDs. Work practice, huge pain points. This stuff is really difficult. It's costly. ROI. At the minute, post-production of stereo stuff is running at about 10K per screen minute. Yeah, I mean, it may be fine as a kind of academic exercise, but as a real-world thing, if something 2D comes along that is higher resolution and much better experience for the viewer, that's the way the market's going to go. Value add, yes, but in an enthusiast community, and we're talking kind of gaming people here, people who tend to have HMDs and stereo stuff. Novelty, yes. Trend, yes. Aspiration, it's kind of beyond the reach of a consumer. A consumer stereo camera at about 8K resolution is not a probability here. The viewing's mainly a bad experience, and again, there's a big thing happening with spherical in general, which is, again, it's a disruptive thing to the social currency of images, the way we kind of deal with images. You're throwing people into a movie with no direction. And they're not a director, they're not an editor, they don't know where to look, they don't know what the story is. So there are big issues around that. So here's what I would call an optimal breakdown. Differentiator should be through resolution and image quality. Cost efficiency should be an end-to-end solution, including the delivery, so the pipeline should be easy to manage, as few pain points as possible. The equipment needs to have market value. Like, if I'm going to invest in this, it's going to earn me money, and I can offset that. I can gradually pay off the capital, expenditure. Infrastructure. We need standards. Really need standards. And we need to get the cost, down to, on the professional end, about $100 per screen minute, not, $10,000. On the consumer side, it needs to be more everyday part of their viewing experience, so they're not having to make a big effort. Doesn't need to be novel, it needs to be familiar. Not a trend, but an established practice. They need to have a good viewing experience. And again, something that you see kind of adding to the social currency, the social language of the images. So myself and my co-author, Dave Newman, kind of looked at this and thought, what's going on here? So at the minute, we've got 2D spherical up in the 4K realm. We've got 2D spherical in 8K and also 3D VR spherical very much in 8K at the minute. And what's going to happen with this? How do we see this happening? So I see that shrinking because that's going to grow. 2020, we're going to get 8K decode in phones and everything. So 8K is going to be the way we're going to share this. The 3D VR spherical, I think that's going to shrink as well because the broadcast, the pro end, is going to push above 8K into 16K. something like that. So this is kind of a global analysis of what's happening. But we're forgetting something there, and that's this area down here, which is what Microsoft are now calling mixed reality, augmented reality stuff. So this will create an incredibly strong market pull, yeah, to generate content for this. Because this is going to be much more involved with people's everyday lives. You know, I've got an old car in my garage, an old Land Rover, and I want to kind of do a resto mod on it. But I want to wait until I can get the HoloLens with the full Land Rover manual in it in 3D. So when I'm messing around with spanners, I can see exactly what I'm doing and know what that bit is connected to and everything. I see this as, you know, incredibly socially kind of useful and powerful. And that's going to be a big driver, because it's a platform on which you can put apps. So this is, you know, I think, you know, 3D VR will continue, but there are big pulls into kind of different regions there. And we've got all sorts of reasons for that, as shown there. It's very interesting that IMAX just announced they're working on kind of VR experience with Star VR, who do have the twin screen, you know, I think it's 4K per eye viewing system, because they understand how to deliver a good, you know, consumer experience in, you know, 3D stereo, HoloLens and everything else. So let's look a bit at what's happening. Really, with my colleague David Newen, we're looking at compression. So it's like what's going on at the minute to influence the way that, you know, we're looking at compression and building standards for compression. So in the mono world, we've got video, we've got single image, multi-spectrum burst, which can be dealt with, you know, through computer vision, metadata, and stuff like that. So yeah, that's all very well known. In the spherical, we've got 2D, we've got 3D spherical, and that kind of connects through with ambisonics and everything, because you need 3D audio to go with, you know, spherical images. And then we've got these exotic things at the bottom here, free viewpoint media, 4D capture light field photogrammetry, which could be anything: pixels, voxels, point cloud, polygons, you name it, waveforms. I had spoken to someone yesterday who said that you could kind of quantify a pixel as a waveform. Very interesting stuff. So what's happening in the world of MPEG? So at the minute, we're kind of struggling a bit with H.264. It kind of peaks at 4K. Doesn't go beyond that. Level 5.2 should take us to 4K P60. HEVC is only a draft proposal for 8K, and they kind of got their fingers burnt a bit on HEVC because they made it too expensive. But HEVC promises really good performance once you get above 8K because of its structure, 64 by 64 microblocks. It's much higher performing, and some people say it may be even a 2x performance gain on that. And there's organizations or groups like the JVET group, Joint Video Exploration Team, who are pushing for spherical standards. And interestingly enough, they're looking at not only rectangular, but also cubic and other kind of ways of encapsulating spherical images, and using actually real test data that, you know, GoPro was producing to actually analyze the compression there. RAW is a big thing coming up, because once you go above 8K, RAW really becomes a good option. Displays are going to be HDR, 10-bit. There's going to be a market pull there. People want, you know, more bits. They want to see better dynamic range. And there are compression issues to do with spherical as well, motion vectors. Yeah. because however you compress spherical, you're distorting it, and your motion vectors are going off, not in a spherical way, but in a kind of stretched 2D way. And the professional market is going to require iframe. So 3D stereo. So over-under, I see everything now mostly comes through as over-under, like the Odyssey stuff from Google is over-under. Interesting enough, encoding at 8K is not yet on the table as a standard. So the MPEG committees are being a little bit more driven by looking, where is the market pull here? We don't want to load a standard, unnecessarily with something that isn't going to be a big market. So they're kind of hedging their bets at the minute. They're saying we're not sure about spherical stereo stuff. And chips. So Umbrella just announced the H3, which will do 2 4K P60 in H.264 or 1 4K 8K P30 in H.265. So they're obviously seeing, a market coming up. And, there's the option there to do 8K as well. But nothing beyond 8K. Yeah. So let's just put that in context here. So this is how we think the market's going to unfold, and this is where what compression, what codecs you're going to be using to do that. So RAW, VC5, and wavelet are going to take a big part, as is VP9, VP10, and AV1. Right, I'm going to skip that, and let's do the blue one. I prefer the blue one. Okay. Now, 3D. I thought it was interesting, the last speaker, Japanese guy, talking about education and what is the value of stereo in education. I would say, what is the value of 3D in education? Okay. So I'll tell you what this is. This is a 16K 3D capture that is done purely optically. There's no time of flight here. There's no active, depth laser shit. This is just cameras, yeah, at about a gigapixel, for the initial capture. And this is showing at half res. I just want to show you the kind of fidelity that is coming out now. And very soon, this will be 4D. This will be not a still image, but a moving image, a moving three-dimensional image at this sort of resolution, which I can stream and play on my laptop here, direct from the web. So I think there are other ways of seeing three-dimensional stuff which are coming, which are maybe going to be more easy to share, to view, that do not disrupt us so much with goggles and everything. So I guess my conclusion, which I should come to very quickly, is we should be aware of that. Yeah. Okay, I think that's it. Yeah.
Jacek Tymiński, Nikon Research Corporation. How many cameras were used to shoot this 3D image?
About 100.
100 cameras.
Mm.
So, if I may ask a question.
Yeah.
Keeping in mind his personal opinion, of course, is you mentioned that you had some very strong opinions about the demise of the 3D market. Would you care to relate to your opinions or not?
Oh, sure. I've mentioned it before in previous talks. The standards committees, I know because I've been a SMPTE member for a long time, and IEEE not so long, but anyway, before 3D TVs became widely available, they were telling the manufacturers it won't work at HD resolution. Of course, you're halving your resolution, so each eye sees half HD. There's not enough pixels for 3D to work properly. The brain needs more information. Yeah? So,
Okay.
but the thing is, people put the glasses on, oh, wow, it's 3D, I can see 3D. But eventually, because you go to the cinema, you see 3D movies, you go home and you see the crap on your own home monitor, and you go, oh, actually, no, I'd rather go and see the movie, which is exactly what happened. The market for 3D in the cinema became really established, and the home market crashed.
So it simply wasn't good enough.
It wasn't good enough. But they were told before it wasn't good enough.
Steve, I think Bjorn had a question.
Raise your hand.
Yeah, thanks for this very interesting talk. One special question. So I was a little bit surprised because you said that the standard format is top-bottom. So I would have expected that it's now because of the HMDs side by side. So for example, if I used to look at YouTube videos, that this would be the standard format.
Yeah,
Why
there's an issue with side-by-side in the way that you kind of uncompress the image and you introduce some artifacts there which are kind of more painful than the over-under one. This is the feedback I'm getting from people in the standards committees looking at, these, like the JVEC committee. They're looking at this and kind of quantifying it and saying which is better and what happens when you do this. So although there are sort of methodologies out there at the minute which seem kind of practical, they do have consequences. And at the end of the day, like I said, the differentiator will be image resolution, which has to include all these things. Yeah.
There's a question in the front.
Yeah.
Yeah, hi there.
Yeah.
Ram Narayan Swamy from Intel. With respect to standards, as we start using multi-camera for 3D, there's a lot of compression that needs to happen. Otherwise, we're going to drown in all this data.
Yeah.
Which of these standards you mentioned are addressing that aspect of it?
I think people are saying, like I said, this HEVC looks very promising. But essentially, you're going to have a lot more data. And you're going to have a lot more memory and a lot more processing power. But that's just a question of, we wait a couple of years for Mr. Moore to come along and say, here you are, So it's, I think everybody's just waiting for, Moore's law to kind of catch up with our aspirations. And it's happening. The Samsung, PCIe-based memory, is there now. High bandwidth, high storage, capacity memory. So we're seeing things begin to happen, which can take us there.
Well, there's some visual clues in there that, with respect to occlusion, disparity, that kind of stuff, which is more key than some of the others, right? Is the standards sort of starting to think about how to encode those vital information, maybe encode less of the standard things at infinity which don't change as much, kind of stuff?
Yeah, I imagine they'll get there in the end. I think at the minute, the mountain to climb is just for 2D, spherical stuff. I'm coming at this from the spherical aspect because I've been, as you see, mainly involved with the design of spherical systems. So we did a deep dive into what happens, when you do that. And like I said, it's a differentiator thing. So at the end of the day, if you can deal with occlusions, if you can deal with glitches, if you can deal with all this, and deliver a good experience, then that'll win out. But I don't think there's enough test data out there at the minute for people to really get to grips with it. We're starting to see algorithmic stitching, like the Google Jump thing and the Odyssey. They do the algorithmic, optical flow-based, healing of the stitching. And Facebook, has made available, algorithmic stitching as well. But that's based on depth analysis. So again, for that to work properly, again, it forces a kind of architecture on your system, which leads to certain kind of, and a certain conclusion. It's large, it's heavy, it has big disparities and big overlaps and stuff like that. So it's not an easy question to answer at this minute. Yeah. All I can say is that perhaps 2D is going to, kind of eventually kind of win this battle.
John Merritt.
Hi.
Isn't it true that that image there contains all the views needed if someone wanted to view it stereoscopically? So that that capture there is suitable for viewing stereoscopically, I would think.
Yeah. When you get to this point, there is no differentiator. You know, like I said, from all those, like the 4D photogrammetry and all that sort of stuff, you end up with data that you can represent in any way. We could take the data for this, yes, and turn it into a 3D stereoscopic movie. It could be a 2D thing. It could be a 3D object. It could be a printed real-world object. There is no, do you know what I mean? All these kind of differentiators go away. And if you have a stereo system, you just hit, I'll have it in stereo, please. Yeah.
Along the lines of objects, maybe one challenge to throw down is, this is like a gender issue, frankly, is that, we've, in the image processing community, we've all used the same standard test object or test image of a centerfold, right, Lena? And I wonder if we're in the early days of assessing 3D model quality. I understand the point here was to look at cloth from close up, but perhaps there's non-human test objects we could choose as standards going forward for this interesting work. I have a question for you, which is not meant to be irritating, but it's something that kind of stuck out to me. So the first half of your talk was about achieving the ability of this sort of massless perfect camera like you saw in Lara Croft. And that's a really cool way of looking at the world. But I noticed your examples that you chose are arrangements of cameras which occupied the volume of less than a microwave oven, say, or a refrigerator. What's wrong with considering the free viewpoint video methods in which the cameras occupy a stadium or a virtualized reality that
I think we're beginning to see that. I mean, Intel is working now with, is it Real 3D? Or I've forgotten the company that does the playback thing for the Super Bowl. Replay, yes. So again, that's coming. People are seeing, we're kind of on the cusp. And it's all down to post-processing. You've got to have a super big pipe and engine kind of crunching those numbers because the amount of data is extraordinary.
So those are valid in your worldview?
Yeah.
Okay.
Yeah.
Got it.
I think the thing is, for me, the kind of pleasure has been to go from, my early cameras to, you see the Lara Croft thing, and then you end up in this space where actually it's just data, and the representation is anything you want. It's just the data capture that's a big issue. How do you capture that data? How do you store it? How do you process it? So I'm just hoping I live long enough for that. So please.
So maybe we have time for one more question. It's kind of on the edge. Going once? Going twice? All right, thank you, Mr. Macmillan.
Okay.